Hey there. In this live stream, we're going to be talking about, I think the title was 90% cost savings with serverless. Is it possible, right? And, the first thing that I want to kind of bring up here is that it is possible. One thing that I've seen from doing serverless consulting for so long is that with each different client that I work with, they're getting some benefit out of serverless. And so just let's look at it from like a raw cost perspective, right? So when you build an application, traditionally, you would build a cloud virtual machine. You would build containers potentially if you're a little bit more advanced with software development. And these two paradigms typically will still run 24/7. So even if your application is not getting heavy usage, you're still going to have to pay for that capacity because you're paying an hourly price. And your users could be all around the world. Somebody could be up at 2 o'clock in the morning, and you don't want your portal to not work because it's 2 in the morning. So because of that, what ends up happening is that people struggle to, with the cost of everything. And so that's where we've kind of made this transition to functions as a service and to cloud functions. And so the big cost saving piece where people see really big gains just in raw cost is actually turning off the 24/7 servers and actually running things on a request basis. And so just to kind of pull something up here, uh, that would be something as, for instance, virtual machines to something like AWS Lambda. So that would be AWS EC2 to AWS Lambda. You could do the same thing moving from containers such as ECS or EKS now to AWS Lambda. And that's going to help you on the resource costs. And that's pay per use versus hourly. However, where does it fall down, right? Where does this not actually make sense? And it may not make sense, for instance, if your application gets very high traffic, right? So if you're constantly getting tons of requests, we're talking 10,000 requests, per minute, 20,000, 50,000, those type of things. Actually, let me dial back. Actually, 10,000 requests per second. Things like that. When you're at that scale, Lambda, it's going to have a hard time keeping up, and there's a lot of different paradigms that have to change within your company to actually support something like that. So we can get into a very high cost scenario using AWS Lambda for high traffic applications like that. It's getting better, but that would be one clear downside of, if we're evaluating an app that you might transition to serverless, you might want to hesitate on the very high traffic applications. The other area that I would focus on for cost saving specifically to actually achieve, these numbers of can you save 90%? The answer to that is yes, right? We've seen tons of case studies around, 88% cost saving, 90% cost saving, 70% cost savings. They're all across the board, but it only is talking about the resource cost, right? If we actually look at the wider view of that, if we think about like team cost, for instance, right? So what is the team cost for not having to run an operations team that's having to manage these servers and not having these people that are on call 24/7 to if issues are taking place, right? What happens when we offload the responsibility of actually building these things from scratch to a cloud provider that has thousands of engineers that work on these services to harden them for millions of customers, right? The answer there is you save a lot of money in the areas that you don't actually see, right? So that's one area which would be people literally working on the app. The other area would be maintenance, right? So like as you're building new things, the productivity levels of your developers, the productivity levels of your development team, that's where you get that extra benefit as well. And that cost saving side is also much harder to calculate than just looking at what is the raw resource cost. But in that area as well, you're saving a lot of money. And so that would be a big one. So you have team cost, you have productivity gains, you have reduced resource cost. We talked about high traffic applications. Another area that I would want to focus on, AWS Lambda specifically, or cloud functions in general. When you're in a pay per use model where however long that function runs, the longer that it runs, it's the longer that you're billed, right? And so the one thing that you want to do is you want to make sure that you have very small functions, right? And so I think like when serverless was first coming about and it's still being talked about very actively now, the easiest way to build out a Lambda function system or a backend with Lambda or with cloud functions is to have what's called a monolith, right? And so people build monolith AWS Lambda functions or cloud functions where they basically have, one single point of entry. All the API routes go to single cloud function in the background. That cloud function will then handle everything, right? And from the development perspective of actually building something like that, that is the easiest approach, right? There's less things to worry about. There's less infrastructure as code. However, it starts breaking down when you actually start getting into bigger companies, mid-sized companies, startups that are getting a lot of traffic, and larger companies, because that extra duration on each function invocation has a whole bunch of downstream, consequences. The first one would be concurrency, right? So the longer that the function is taking to finish, the less concurrency you get. Concurrency would be if I get 1,000 requests per second, and my duration for my function is like 500 milliseconds, then potentially that's like what is that, like 2,000 concurrency per minute, something like that. So the big thing to know though is that the longer that the functions are actually running, the duration of them, the less concurrency that you're going to get. The other side of it is the more you're going to get billed, right? So the duration being, let's say, for an app that was getting 500 million to 1 billion invocations per month, what they're going to see is that an extra 100 milliseconds of time is actually going to increase your cost by like roughly roughly $3,000 a month. So for every 100 milliseconds, which doesn't seem like that much, it's going to increase your cost by that percentage. Oh, hold on. Cat. 1 second. Come on, Chow. Oh, all right. There's my cat. Okay. Yeah. So with that, let's move to another area. So as I said, avoid monoliths. You want to keep everything small. That's going to help you with the duration. It's also going to help you with the cost of it. It's also going to help you with concurrency. So, and the other side of that too is your actual users, right? So your users will be able to get faster responses because there's going to be less cold start. So a problem that happens when you build cloud functions is when the actual request comes in, it has to spin up a container and has to actually put your code onto that container. And then after your code executes and finishes, then that container is going to die, right? It may take 3 minutes, 5 minutes, etc. I'm not going to get into what cold start, the nuances of it for different cloud providers. The big thing though is that cold starts mean additional time for your users. So that's a user impact. So if you can keep that function small, right? So what we're talking about, like what is small, right? Well, apparently with the Firecracker system that runs underneath AWS Lambda, it's recommended to keep your functions 5 megabytes or lower. And if you keep it 5 megabytes or lower, you're going to avoid cold start. And so what that means is that you're going to get these really fast requests all the time, guaranteed, that type of thing. Versus if you had a 50 megabyte function, it's going to take even longer to spin up. And that's where you can see 300 milliseconds, 800 millisecond cold start times. And that's going to have a big impact on your users. And of course, with the nuances of cloud functions and the container reusing across multiple, requests coming in, there can be situations where maybe that first request is going to be slow, but then the next requests are going to be fast. But where it breaks down is that what if you get 10 requests at the exact same time, right? And there was no container that was already running. That's a situation where it may create 10 different containers. You may get 10 cold starts, right? And so those are all areas to be aware of. Something that you can do to kind of combat that cold start time is you can use something like Lambda provision concurrency, and that's going to allow you to actually provision, concurrency so that if you do get that many requests coming in at the same time, your application or your backend code is not going to cause cold starts for your users. That would be like, it's kind of like masking the problem, right? The real problem is that your functions are too big, right? They're doing too many things. If you have a monolith, you have something like it's doing 4 different things, 5 different things, and they're not split up properly, and you're using all of these npm modules that all increase the total size. I actually, I made a very simple bash script. If you go to github.com/serverlessguru/templates and then into bash scripts, you can then see a bash script around 5 megabyte package like validator basically. And what it does is it's going to run, if you're using serverless framework specifically, it'll run an SLS package command, and then it'll actually check to see how big is that zip file before it actually uploads it to AWS Lambda. And if it's bigger than 5 megabytes, and you can of course adjust that, then it's going to break the build. And so what's cool about that is that you can work that into your CI/CD pipelines, and then you can make sure that your entire development team is not running into those issues because you're going to enforce it at that level. And so what it's supposed to condition developers to do is to not use as many node modules, right? I think that a lot of times, even with working with Node.js, we'll need to do something like make an HTTP request, right? And so there are native libraries that you can use to do that. But a lot of times we reach out for request or Axios or some other HTTP node library to do that for us because it's just easier, right? But when you're actually thinking about building these, applications that are going to have to spin up that didn't exist prior, and they're going to have to spin up and then be able to handle a request, the longer that it takes for that interaction to happen, the more impacts for your downstream users and the increased cost of it. So keep it small. Don't do monoliths. Split your functions up. Use something like serverless framework. That's going to allow you to actually break it apart in that way, where you actually have very small functions. And you can go to, you can go to a couple things that we actually have at Serverless Guru. You can go to training.serverlessguru.com, and we have a course that I made a few months ago called Zero to Pay Professional. It's completely free. We're not going to charge you anything. All you have to do is sign up, and then you can actually use it. And it's a series of videos that go, I think it has 96 videos in it, and it goes through building things in the console, building it with the serverless framework. It goes over best practices that I've learned throughout my career. And if you have any questions on that, feel free to hit us up on Twitter at twitter.com/serverlessgurux. That would be one option. The other option is you can go into github.com/serverlessguru/templates or github.com/docs, DOCS. Either one of those repositories are going to have a whole bunch of templates and documentation on how to build serverless applications based on our experience at Serverless Guru doing consulting. Yeah. So can you save 90% using AWS Lambda, using serverless, using these fully managed services? Absolutely. There's different ways that you can do it. Like let's go into a different one. So we talked about cloud functions, but what about databases, right? So with databases, it's a little bit more tricky, but there's new things that have come out that actually make that easier. For instance, let's take DynamoDB, right? So for DynamoDB, for a long time, they only had read capacity and write capacity. And that was like two knobs that you could increase the read or you can increase the write. And you would have to pay for that capacity even if you weren't using it. But now we actually have something called pay per request, right? And so we're seeing a model shift towards other things that are more serverless in nature and more pay per use. We also have RDS. And so with RDS, the relational database service with AWS, they offered MySQL table or MySQL databases, Postgres databases. Then they offered Amazon Aurora, which is more of a fully managed. It's going to handle the auto scaling, multiple availability zones, all those things to make sure that your application is or your database is very hardened, has good backups, all those things, and performance. But then now they actually have Aurora Serverless. And so Aurora Serverless will allow you to also use that kind of pay per request model where it's going to spin up and actually allow you to access your database from there. And so there are a lot of innovations happening in this. But if you literally just took your, I know some companies that I've been in contact with, where they have 5,000, 6,000 servers running every month, 24/7, right? And then you think about the amount of traffic that they're actually getting, and you think about the optimizations that they can make, either by optimizing the existing servers or moving them to containers, doing something like a Fargate mix in there, and or refactoring their application to actually use more Lambda functions, right? Because what we see a lot of times is that companies will actually use backend processing with servers that are running 24/7. And what that looks like is, let's say we have a couple of jobs that will run very infrequently, right? Like maybe it's even our CI/CD pipeline is running on our own server, right? And so that server is not constantly being used for builds, but we run it 24/7. And that's because we want it to be available when some team needs to run builds. But the problem there is that we're paying for a lot of idle time. And that's something that serverless gets rid of. So the more ways that you can get rid of that idle time, the closer that you can kind of wrench down the amount of time that you're spending or the amount of capacity and also, I guess like time that you're spending for your things running when you're not actually using it. That's where you're going to get this really, massive cost savings. So one area that I've seen in that way is that we always think about, well, let's go from zero and then let's scale up, right? But what happens when things go wrong, right? What happens when, you have, what happens now we're in a pandemic, right? Like what happens when the usage of an application drops, right? What happens when there aren't any users, right? There's no revenue coming in. But then you have these very big companies that are paying for all these servers that aren't being used. So how do you actually go about that, right? And the big thing there is that these companies need dedicated teams of people that understand how to scale down their servers properly, how to make sure to cut the instance type sizes, and they need to do that quickly and they do it efficiently. And then if the traffic comes back, they need to be able to scale it back up, right? And so it takes a very expert team of people that actually manage this whole process. Serverless AWS Lambda, these fully managed services, they do it for you, right? So that's a really big benefit. And what you see is that when the usage actually drops, the companies that are using serverless right now, they're getting massive cost savings. Right out of, automatically, they're getting massive cost savings. So if a company was spending, $100,000 a month, and then they were that was $100,000 a month with serverless, with AWS Lambda, with DynamoDB, with CloudWatch, with these other services that are supporting. If it was 100,000 a month prior, let's say like a January or February pre-pandemic, and then we actually get into the drop in usage, that's where that $100,000 bill can drop automatically down to something like 5,000, right? $10,000, and it's because AWS Lambda is going to scale all the way down to the usage. The CloudWatch usage is going to scale down to the usage. DynamoDB is going to scale down to the usage. But then if you were supporting your application with EC2 instances, and you're still running at that same load, or Elasticsearch or Elastic Cache, that's where the capacity that you set, pre-usage drop, that's where it's still going to be costing you the same amount of money. So, my recommendation is, you want to think about both sides, right? You want to think about who's holding the bag, right? Who's holding the bag if usage drops on the application? Where are you spending that money? And can you use it more efficiently? And so without even thinking about the team cost or the productivity gains by the development team, you are managing less, and with that, it allows for all these downstream benefits. So upfront, I would say 90% cost savings, absolutely possible. Even if your entire application is already using serverless, right? If you're migrating from something else to serverless, that might be slightly different. But if you're using serverless and the usage drops, that will give you those 90% cost saving examples. So that's kind of been, I think, a very jumbled way of saying, yes, it is possible. Here are a few different things that you should think about. Hopefully this was insightful enough to be worth the viewership time. I appreciate it. Once again, I'm Brian Jones, the CEO and CTO of Serverless Guru, a cloud consulting company specializing in serverless and also cost savings, optimizations. We do a whole full suite of services. The slogan that we like to use is we help you on every step of your serverless journey. So with that, I'll wrap up. If you have any questions, leave them in the comments, and we'll get to it as soon as possible. Thanks, everyone, and see you next time.